give you some examples of AI-driven tools and really talk about some of the challenges and opportunities. So when you think about the history of AI, really it's been around for a long time, somewhere between the 1950s and 1970s. It was actually coined in 1956. The concept is old, but it's only really gained popularity, why? Recently, and why is that? Really because the data was not enough previously for true prediction, which is what we're all looking for. And really what's happened is that it really is a digital world when you look around, right? We've got smartwatches, we have monitors that will watch how we sleep, how we breathe, how many steps we take. So it's really become a digital world. And digitalization is really the enabler for artificial intelligence and machine learning. Data is a new game changer everywhere. We've got data everywhere you look, we have data. And how do you organize large volumes of data, real-time data? And to do that, it's extremely time-consuming and can be quite slow. And what we need is efforts to reduce the human effort. And this is what artificial intelligence and machine learning is really being used for. So machine learning, if it's designed, validated, and implemented, can really help in acquiring, interpreting, synthesizing healthcare data from multiple sources. And imagine seeing a patient and getting their remote patient monitoring, talking to the patient, their physical exam, their laboratory. There's a lot of pieces of data, but putting all of that together, that's like as you say, an expert subspecialist on call on every patient and for every clinical situation. And that's really the promise of machine learning. Now, artificial intelligence, just to put it into perspective, is a large bucket. And within artificial intelligence, you have machine learning, you have DL, which is deep learning, and then you have natural language processing. All of that encompasses artificial intelligence. And what it really does is leverage those large data sets, increases the computational power to really make efficient decisions on complex decisions. And then the machine learning data processing is what helps. Now, what is artificial intelligence? I gave you that, but really we think about it as a computer that reasons like a human, right? It's able to perform tasks associated with intelligent people. Machine learning starts to come into an AI that automatically adapts with very minimal human interference, training on smaller data sets. That's machine learning. But what is deep learning? Well, machine learning that learns on its own from the environment and past mistakes requires a lot larger amount of data. That's what we call deep learning. And so traditional analytic models for ambulatory monitoring takes a signal, processes it, puts it through an algorithm, and then says to the physician, hey, there's a problem here. So when you think about the cardiac implantable electronic devices, that's how the devices got their signal and they were able to apply therapy. But now, all these new models are using the machine learning technology, so they're taking multiple data sets and then doing the actionable output so that it informs the patient as well as the physician about it. So slightly different way of processing, but able to look at multiple data to make a decision and not just one data set. Now, there are many steps in machine learning. We don't have time to talk about that, and that's really not the purpose of this talk. So, as they call it, the 7 steps of machine learning. But there's also lots of things that we can talk about when it comes to machine learning, and there are many flavors of machine learning. There's supervised learning, there's unsupervised learning, and there's reinforcement learning. But really, that's not what we're in here for. It all sounds complex, but really, the bottom line is we're in transformative times, and it's transformative healthcare as we know it. And COVID-19 really was the catalyst of that, right? Silicon Valley in the United States has been telling us for over a decade that we're in the midst of a digital transformation of healthcare. Well, what did that mean? Well, overnight, we sort of became somebody that actually started adopting that digital transformation. So if you look at March of 2020, prior to that, only 5% of uptake for telehealth in the United States and in the world. And during the peak of the pandemic, it was 90%. And now, we have settled into about 30 to 40% of the cardiology visits in the United States are still telehealth. Now, we realize that telehealth is just a platform. What we really want to do, if you think about the continuum of healthcare, is we want to do virtual care. That requires a telehealth platform. It requires remote patient monitoring. and then an artificial intelligence-driven data processing. And if you put those three pieces together, that is what we need for true digital transformation, for at least in cardiology. So when you think about the different components, recognize that we have a lot of things. This evolution of digital care allows us. So this particular picture shows a lot of the devices that could provide us information for that remote patient monitoring, right? So you can do an ECG, and how many people can get, so we have patients that buy these Alive Core, and they're able to do ECGs, and they'll tell me, they said, oh, I'm in atrial fibrillation. How do you know? Well, I didn't feel well, and I did an ECG, and it reads out atrial fibrillation, or their smartwatch tells them that. And then they can just send that to the office and then be seen if they need to be. So what we want to do to get to virtual care is have that telehealth platform, that video, or a telephone visit, but then add the middle piece, that remote patient monitoring, to get biometrics, to get weight, blood pressure, all of that. Ultimately, what we want to do is create management pathways and then therapeutic pathways to really get to virtual care. And so that's the remote patient monitoring piece. And if we think about AI-driven piece, that's what's going to help us with this management pathway and therapeutic pathways. Why? Because it can process all the data to tell us what is the best management and what are some recommendations for therapeutic programs. Imagine it saying, we know that there's quadruple therapy for heart failure, but maybe the clinician didn't think it was appropriate, but an AI-driven would nudge them and say, this patient may be very appropriate for quadruple therapy or addition of a therapy, and that could sort of nudge the clinician to maybe feel more comfortable about using it. So I think cardiology is definitely, over the last several years, and you've heard about at the meeting all of the new things that are happening, and what we've come to realize is that we have to have creative approaches to care. And I think that there is a lot of increasing importance of artificial intelligence in healthcare and in medicine, but particularly in cardiology. I've given you a lot of examples of AI-driven care in cardiology. That's me at the using a robotic PCI. There's a lot of artificial intelligence in that robot. You have the smartphones and imaging. Artificial intelligence has really been very, very helpful in intervention, in helping detect early ailments and treatment decision-making. So lots of things where we have seen AI-driven care. You may not even realize that there's AI playing a role in a lot of the stuff that we do. This is an example of how AI may be used in STEMI management, particularly in women. This uses predictive modeling of features of STEMI to provide a standardized approach to care, and it can eliminate the implicit bias in terms of caring for women and improve the STEMI care and eliminate sex disparities. So that's another sort of novel use for artificial intelligence. This is a potpourri in the next few slides of all of the different things that are being published with artificial intelligence and coronary artery disease, unsupervised learning for AI coronary artery disease, machine learning models for predicting patient mortality in coronary artery disease, AI-enabled ECG algorithms for patients with atrial fibrillation, learning from electronic health record and genetic data to improve cardiovascular event prediction. So these are just some of the examples. There are many opportunities. There's all these papers written about the opportunities and how big data is going to help us in terms of cardiovascular research and what are the challenges for that. Deep learning for cardiovascular medicine, a practical primer. So you see there's a lot of things. So in 2022, these are some of the articles that have been published looking at this topic. So if you don't think this is important, let me tell you how important it really is. And so I think the future really is artificial intelligence. Now, I will tell you, for those of you that are worried that that's going to replace us as clinicians, automation won't ever replace a physician. But those using automation will replace those who don't use automation. And I think there are certain medical specialties with many repetitive tasks that will be heavily impacted, while others requiring more creativity and interactions might not. So do the predictions actually translate into meaningful clinical benefits? And that is the data that we need to really make this go forward. So what are some of the challenges? Well, there are many. There are obviously some regulatory concerns. Are there biases implicit in these training sets so that you can skew the way that you think about particular populations? What about what goes into a data set? Is there lack of transparency that could occur? What about privacy concerns with the data used for AI models? And then the safety and liability issues. And then does it really work in real life? And I think those are the challenges. So looking to the future, I think, honestly, for this audience and what I say to my cardiology colleagues around the world is that the best way to predict the future is to create it. And I believe that the world is about digital transformation, artificial intelligence, and I think it's time for us all to embrace this, be involved, and help create the pathways. So thank you for your attention.